So next we do another problem. Find the equation of the straight line passing through the points passing through the point actually. Passing through the point 3 comma minus 4 and making x and y intercepts which are in the ratio 2:3. So, how do we proceed with this problem? Now, this passes through 3 comma minus 4. So, this point is in the fourth quadrant. And then it says it makes x and intercepts, y intercepts which are in the ratio 2:3. So one thing is this 2:3 ratio, this, because minus sign is not given, so this means either both will be positive or both will be negative. So how to do this problem? So let A be the x-intercept and B be the y-intercept. Then, since A is to B is equal to 2:3, since A is to B equal to 2:3, let A be some 2k and B be 3k. Okay, so this is the proportional. So now when you multiply by a proportionality constant where k is proportionality constant, what does it do? It gives you, when you multiply 2 with k, it gives you the exact value of a. When you multiply 3 with k, it will give you the exact value of b. So A is to B is 2k is to 3k, which is 2:3. So that's what it does. So now, therefore, the equation of the line in the intercept form equation of the line in the intercept form is x by a plus y by b is equal to 1, which implies x is equal to x by 2k plus y upon 3k is equal to 1. Okay. Now, what is given? It is given that the line passes through 3 comma minus 4. since the line passes through three comma minus four, we get this 3 comma minus 4 should satisfy this equation. So substitute 3 in place of x and minus 4 in place of y. So we get this. So take k to the other side or multiply 4 by k. So we'll get 3 by 2 minus 4 by 3 equal to k, which implies k will be equal to 9 minus 8 upon 6. So k is 1 by 6. So value of k is 1 by 6. So this is how we found the value of k. First assumed a as 2k, b as 3k. Then wrote the intersect form of the line. Then after that, we substituted the point 3 comma minus 4 in the line, the equation of the line, because that satisfies the equation. So from there, we get the value of k as 1 by 6. Now, therefore, the equation of the line is x upon 2k, that is 2 into 1 by 6, plus y upon 3k, 3 into 1 by 6 is equal to 1. So 2 divides 6 3 times, so we get 1 by 3 in the denominator. Taking that to the numerator, we get 3x plus 3 divides 6 2 times. So that 2 comes up. So 3x plus 2y is equal to 1. 3x plus 2y is equal to 1. So this is the equation of the line. Okay, understood how to do this? Very simple. Find the equation of the straight line passing through the point and making x and y intercepts which are in the ratio 2:3. Next, question 2. Have you taken down? Can I move forward?
Yes, sir.
Now look at this. Find the equation of the line passing through the point 4 comma minus 3 and perpendicular to the line passing perpendicular to the line through the points 1 comma 1 and 2 comma 3. How to do this problem? Sorry, screen sharing. Now, so we have this 1 comma 1 is here and 2 comma 3 will be here. Okay. Now, this is one line through these 2 points. We did not do this, but we did not do a geometrical figure. You don't need it for this problem. But I am helping you to give a visual picture. So this is 1 comma 1, and this is 2 comma 3. Now 4 comma minus 3 will be somewhere here. And there is a line which is perpendicular to this line and passing through this point. Now, so how to do this? We want to find the equation of this line. So what is given, what is known to us that it passes through the point 4 comma minus 3. And what do we need to find? One more condition we need to find. We know it is passing through a point. If we can find the slope of this line, then we can use the point slope form of this trick to get this equation of this line. So how to do? It is given to us that another line is perpendicular to the required line, and that line passes through 2 points. So once we know that it passes through 2 points, we can find the slope. So let us do that. We can find the slope of that line. From the slope of this line, the slope of the required line we can find, because the product of slopes of 2 perpendicular lines is -1. Okay. So how to proceed? So let M or M1 be the slope of the line whose equation is to be found. Now let M2 be the slope of the perpendicular line. Let M2 be the slope of the perpendicular line. So now the slope, since this line passes through 1 comma 1 and 2 comma 3, slope M2 is equal to y2 minus y1, that is 3 minus 1, by x2 minus x1, 2 minus 1. So slope is 3 minus 1, 2 upon 1, that is 2. Now, since the above 2 lines are perpendicular, we have the products of slopes is equal to -1. So m1 into m2 is -1. The slope of the required line and slope of the other given line passing through 2 points. Okay, the slope is product of the slopes is -1. So which implies m1 is equal to -1 upon m2, which is -1 upon 2. -1 upon 2. Therefore, so we found m1 and it passes through this 4 comma -3. So we found m1. So m1 is equal to -12. All right. Now, since the required line passes through passes through 4 comma -3, the equation of the line is y minus y1 is equal to m1 into x minus x1. We are using point slope form. So y minus of -3 is equal to m1 is -12 into x minus 4. It passes through 4 comma -3 and the slope is -1/2. So we get y plus 3 is -1/2 into x plus 4. Take this 2, multiply 2 from this denominator, take it to the numerator on the other side of the equation. So you get 2y plus 6 is equal to -4 or -x minus 4. So we get, bring this x all terms to one side, we get x plus 2y plus 10 equal to 0. This is the equation of the line. So this is the equation of the required line. X plus 2y plus 10 equal to 0. Good. Clear? Okay. So this was another important question. Now, the the third question, second bit, I will do. There are 3 bits. Other 2 bits you should do. Show that the following points are collinear. Show that the following set of points are collinear and find the equation of the line containing them. So the set of points given are one comma 3, minus 2 comma minus 6, and 2 comma 6. So how to find whether the points are collinear? There are two methods. Method 1. To check that 3 points are collinear. We verify, to check that 3 points of collinear, we verify the determinant of 1 x1 y1, 1 x2 y2, and 1 x3 y3 is equal to 0. Okay. Now, so this implies we have to check. So consider. So therefore, consider the left hand side. Consider 1 x1 y1, 1 1 3. Next 1 minus 2 minus 6, 1 2 6. So we need to evaluate this determinant. Now, how do we evaluate determinants? The determinants are evaluated like this. We can expand this determinant or evaluate this determinant across a row or across a column. Okay. So let us do across a row. Some of you may be, one of you may be familiar with this, or both of you may be familiar with this, how to evaluate determinants. If not, then hear this, how to evaluate determinants. So we take the first row, 1, 1, 3. Okay, 1, 1, 3. The elements of the first row. First row is associated with first row, first column. This is row, this is column. First row, first column is associated with plus sign. The next column is associated with minus, next plus. Okay. So first you write this. After that, for this first element, you multiply So now what you should do to evaluate, because I am considering this element, I omit this row and this column which contains the element. I omit the row and the column which contains this element. Then what am I left with? I am left with this, because I have eliminated this row and I have eliminated this column. So I am left with this minus 2 minus 6, 2, 6. Now what I do? I do a cross multiplication. Minus 2 into 6 is minus 12. Then 2 into minus 6 is minus 12 again. So minus 12 minus of, so when we come from upward to downward, from left to right, it is positive product. When you go from downward to upward, it is a negative product. So positive times minus 2 into 6 is minus 12. Then minus of 2 into minus 6 is minus 12. So what did we do? 1 times minus 2 into 6 minus of 2 into minus 6. Okay. Next, for this one now, okay. Now for this one, the first row, second column, what do? We should eliminate, or we should neglect the row containing this element and the column containing this element. Then what are we left with? 1 minus 6, 1, 6. So 1 into 6 product, 1 into 6 is 6, minus of 1 into minus 6, that is minus 6. All right. Then the last one. Now you will be able to tell me the last one. We are dealing with this element 3. 3 times eliminate the row and the column containing 3. Then we are left with 1 minus 2, 1, 2. Now their products 1 into 2 is 2, minus of 1 into minus 2 is minus. So that, so this is how we evaluate determinants. Okay, so what we get is 1 times minus 12 plus 12 is 0, minus of 1 times 6 plus 6 is 12, plus 3 times 2 plus 2, 4. So this is 1 into 0, 0, minus 12 plus 3 into 4, 12, 0. So since this determinant is 0, since the determinant is 0, the 3 points (1, 3), minus 2, minus 6, and 2, 6 are collinear. All right, this is the method. Check the determinant. We have to verify that this determinant is 0, and we calculated and we found that the determinant is 0. So the 3 points are collinear. Now method 2. Okay, to check the 3 points, say A1, 3, we are naming the points now. B minus 2, minus 6, and C 2, 6. To check the 3 points A, B, and C are collinear, verify that slope of AB is equal to slope of BC is equal to slope of AC. Any need not be 3 of them. Of these 1, 2, 3, take any 2 they should be equal. So if the slopes are equal, then the points are collinear. Okay, AB and AC, AB or BC, or BC or AC. So anything you check, it should be of the same slope. So let us check this slope. Slope of AB. Or I'll write MAB. M subscript AB, meaning the slope of the line joining the points A and B. So y2 minus y1 by x2 minus x1, minus 2 minus 1. So we get minus 9 by minus 3 is equal to plus 3. The slope is plus 3. Now slope of BC. Slope of BC. So this is x1, y1 now. This is x2, y2. So y2 minus y1, 6 minus of minus 6 by x2 minus x1, 2 minus of minus 2. Now 6 plus 6 is 12. By 2 plus 2 is 4. Plus 3, sufficient. So slope of AB is equal to slope of BC, which means the points are collinear. The points are collinear. They lie on the same line. You did not check for AC, but here we can check for AC. You can do anything. In exam, you just have to check any two. Slope of AC. Now A becomes x1, y1, C becomes x2, y2. So y2 minus y1, 6 minus 3 upon x2 minus x1, 2 minus 1. 6 minus 3 is 3 upon 1 is 3. So all the three slopes are equal. Therefore, the points A, B and C are collinear. Now, you have found the collinearity condition. Equation of the line, you can use 2.4. To find the equation of the line, we shall use 2.4. Passing through A, say 1, 3 and B minus 2, minus 6. So what is the 2.4? Y minus y1 is equal to y2 minus y1 upon x2 minus x1 times x minus x1. This is the 2.4 of the line. So we get y minus y1 is 3. Y2 is, of course, we know this slope. We already have calculated, but so minus 6 minus 3 upon minus 2 minus 1 x minus 1. So we get y minus 3 is equal to 3 into x minus 1. This is the equation of the line. We can simplify further. This is 3x minus y is equal to 0. Because minus 3 cancels on both sides. This right hand side becomes 3x minus 3. So that minus 3 here and minus 3 here cancels. So we have 3x minus y equal to 0. Okay, this is method 2. Now method 3. Now method 3, one other method is, suppose there are 3 collinear points. So then method is the equation of the line through any 2 points must be satisfied by the third point. So the third point lies on the same line. So that it should satisfy the equation of the line passing through A and B. So the equation of the line through A 1, 3 and B minus 2, minus 6 is y minus 3, y minus y1 is equal to y2 minus y1 by x2 minus x1. We get 3 slope into x minus 1. So we get from, I'm not repeating this step, I'm doing this step only. So we have y minus 3 is 3x minus 3, which implies y is equal to 3x. Now, if C 2, 6 is collinear with AB, it must satisfy the above equation. And which it does. So y is equal to 3x implies 6 is equal to 3 into 2. So 6 is equal to 6. Thus 3 says C 2, 6 lies on the same line. To A and B. Therefore, the given points A, B, and C are collinear. Whichever you are comfortable with, you can do that. There are 3 methods I gave. One is use determinant to find the collinearity. With this, you can find the collinearity, but after that, you need to find the equation of the line. In the second method, check the slopes of any 2 sets, any 2 pairs of the points, AB or BC or AC. Take any 2 segments and find their slopes. If their slopes are equal, then the points are collinear. Again, here we can just show collinearity by this method. This is an easy method than the determinant method. However, we still need to find the equation of the line. passing through the 2 points. Third one is by far the best method, because first you find the equation of the line through 2 points. So that is done. And after that, you check whether the third point satisfies the same equation or not. If the third point satisfies the same equation, then the points are collinear. Okay, so I'll stop here for today. Hope you understood this. These are very important. See, I'm telling you, for your competitive examination preparations, your basic Telugu Academy textbook, you should be thorough with. Every problem, you should have the full grip of the concepts. If you have the fundamental basic concepts, then getting a practice of multiple choice questions is the only, first the basic questions you should have, so that you get thorough confidence in problem solving. All right. If you, do you have any questions?